Good afternoon, students. In the last lecture, we have discussed about electric field due to an electric dipole on its axial position, but here we are going to discuss electric field due to an electric dipole at its equatorial position. Let me discuss this point. What is equatorial? Equatorial means the distance which is same from the both of the charges, that is from minus q and from plus q, it is having the same distance. So let us consider an electric dipole consisting minus q and plus q charge, keeping with that that L and L distance from the mean position. Let a point P which is at equatorial position. From this point, let E1 and E2 be the electric field due to plus q and minus q charge respectively. As we know that due to plus q charge, electric field is always outward. So here E1 would work outward as it is shown in the figure, and due to minus q charge it is always towards, that is why E2 tend towards the minus q charge as it is shown in the figure. But one more thing we know that when something is happening with the angle, that theta angle it is raising up, so it can be distributed into its component. Here E1 can be divided into its component, like vertical component is given by E1 sin theta and horizontal component is given by E1 cos theta, and for E2 it is also given like E2 sin theta as the vertical component and E2 cos theta as the horizontal component. Now thus we can conclude that due to plus q charge, E1 can be given like 1 upon 4 pi epsilon naught q upon under root r square plus L square whole square. It comes from the formula that E is equal to 1 upon 4 pi epsilon naught q upon r square, as we know that. Just because of this, that here E1 is making a right angle triangle, and we know that this arm, that PB arm, behaves like a hypotenuse. That is why it is working like under root r square plus L square. And similarly we can give that E2 is equal to 1 upon 4 pi epsilon naught q upon under root r square plus L square whole square. Like, it can be considered as second equation. Now here we can conclude that from equation 1 and 2 it is clear E1 and E2 are same, both are same. So here E1 sin theta would cancel the effect of E2 sin theta as it is shown, because it is tending towards opposite directions. Now thus the net electric field can be given as E is equal to E1 cos theta plus E2 cos theta. Here we can conclude the value of cos theta, that is base upon hypotenuse. What is the base? Base is given like L and hypotenuse is under root r square plus L square. We are putting the value and we are getting that E is equal to 1 upon 4 pi epsilon naught q upon under root r square plus L square whole square dot L upon under root r square plus L square. Similarly for E2 cos theta it is given 1 upon 4 pi epsilon naught q upon under root r square plus L square whole square and L upon under root r square plus L square. Here as both the quantities are same, so we are adding both the quantities and we are getting that E is equal to 1 upon 4 pi epsilon naught q upon q dot 2L upon under root r square plus L square ki whole cube. Now here under root can be given like power 1 by 2. So here it is written like 1 upon 4 pi epsilon naught q dot 2L can be written like P. So it is written here q dot 2L can be written like P, that is electric dipole moment, and under root r square plus L square whole cube can be written like r square plus L square ki power 3 by 2, just because under root can be given like 1 by 2 power. And here we know that L is very small quantity, then the L square would be more smaller. Then by neglecting L square, what we are getting here, that is E is equal to 1 upon 4 pi epsilon naught P upon r square to power 3 by 2, that is given like E is equal to 1 upon 4 pi epsilon naught P upon r cube. This is your result, that is electric field due to an electric dipole at its equatorial position. Remember one thing, on axial position there would be only 2 and here 2 is not there. So there is only one difference in the resultant of at equatorial position and on axial position, that is 2. Okay.